Okay, we are now going to continue working on page 19. So the last time, yesterday when we were working on page 19, we looked at this model here for the bar model there, and we had said that 17 represents the amount she made at the fair. So you guys will remember this, and that this was the amount she borrowed and paid back. And then we talked about how 9 was the amount that she made after she had paid back. So she made 17 total. So we talked about this using the bar model to write a subtraction problem. And we said that the subtraction problem would be 17 minus 8. And then take a second to write it as an addition problem. It's probably already written in your book, actually, so I will just write it there. And we talked about why this is an expression. And so how are the two expressions related? They both represent the amount of money that Allie made after paying her sister. So then we get to question 4, and this is kind of where we left off yesterday, is what does -8 represent on the number line of the previous page? So this is the number line, and we started here at -8, and so what does that -8 represent? It represents the money that she paid back to her sister. Or another answer could be it represents the money she spent on supplies. Okay, so now number 5, use the number line on the previous page to write an expression to represent the amount of money Allie has after the fair. So we're going to use this number line. So we're at -8, and then we're adding 17 to it. And so, because on the number line we started with -8, so we say -8 plus 17, and that's our expression, our mathematical sentence that doesn't have an equal sign. So now we're going to simplify the expressions that we wrote in problem 2 and 5 to find the amount of money. So we'll say 17 minus 8 equals, and we already knew from up here that it equals 9. So 17 minus 8 equals 9. And then if we said 17 plus -8, we know that those equal the same thing. So that's 9. And then -8 plus 17 is also 9. So when it says simplify the expressions, what that really means is solve the equation. well, you're really not solving the equation because it was just an expression, but we're finding the answer. We created an equation here. Okay, so describe another situation that can be represented by adding a negative number and a positive number. And so that's something that I'd like for you guys to do at your tables for a few minutes. So we can pause the video here and you guys can describe another situation and spend 2 or 3 minutes at your table talking about some different situations that could be described by adding a negative number and a positive number. So one that I thought of was, what if we drove down to in elevation? So if I was on a mountain, so if I draw my mountain over here, and I started here and I drove down, which would be like, let's say I drove down -10 miles, but then I drove back up another 15 miles, I would end up 5 miles further up the mountain. So a situation could be driving down a mountain and then driving up the mountain. A couple of other examples that we've used already in class is points, starting out with negative points in some kind of a game, and then getting positive points. That could add negatives and positives. We've talked about bank accounts where you spend money and then you get more money, and so what does that do to your bank account? We've talked about in other problems about sea level, like a fisherman drops his line down and catches a fish, how far does it have to come back up? That would be adding a negative and a positive. So any of those would work for number 7. So try it. Use what you just learned about adding positive and negative numbers to solve these problems. Write and simplify an expression for each problem and show your work on a separate sheet of paper. So in a trivia game, Joshua gets a score of -4 in the first round and -5 in the second round. What is his total score after 2 rounds? So there's a couple of ways to model this, but we're going to write and simplify an expression is what they ask for. So we've got -4 plus -5. And we learned yesterday that whenever we add 2 negatives together, the answer is going to be negative. And so -4 plus -5, if I was going to draw a number line, and here's 0, and there's -4, and then I go 5 this way, 1, 2, 3, 4, 5. What is this? -5, -6, -7, -8, -9. -4 plus 5 is -9. A balloon is 23 feet below a tree limb. The balloon floats up 19 feet. What is its position relative to the tree limb? So if I draw my picture here, I don't have a brown pencil. I'm about to though. Let's see. And none of those are really brown. There we go. All right, so I'm going to draw my tree limb over here. So here's my tree. And then here's my tree limb. And a balloon Here's our balloon. So this distance here, and you don't have to draw this picture, but I just feel like being artistic. So this is 23 feet below this limb. So the limb is going to be 0 on a number line that goes up and down. The balloon floats up 19 feet. So it doesn't get all the way back up, but it gets up to here, and that's 19 feet. So the expression that we have would be, it starts 23 feet below, so that's negative, just like we've got over here, negative 23. So we're going to put that, negative 23. And then it floats up 19 feet, so we're going to add 19 to negative 23. And so the question is, what is this little space right there that's still there? And the answer to that question is negative 4. So it's still below, 4 feet below the tree limb. We should put some leaves on that tree too. It's a tree that has one big limb sticking out with lots of leaves on it right there. All right, on to page number 20. So we're looking at subtracting integers now. What are some methods for subtracting integers? So in the last little section we were doing addition. So now we're going to be doing subtraction in all of these. So here's our problem. Indy, Mark, and Tess each pick a slip of paper with a subtraction expression written on it. The person holding the card with the greatest value wins a prize. Who wins the prize? So we've got Indy, who we're looking at her slip right here, is 2 minus 3. So she is going to start at 2. So here is Indy. She's starting at 2, and she's starting right there, and she's moving 3 this direction. So she ends up at negative 1. Let's see if we're going to write that here anywhere. Looks like in number 12, we're going to write it as an addition expression. So we could go ahead and just do that and say that 2 minus 3 is 2 plus negative 3. Okay. So then we look at Mark, and Mark starts at negative 7. So he starts at negative 7 right here. And so it says subtracting 4. So negative 7 subtract a negative 4. So subtracting negative 4 is the same as adding 4. So you're going to move to the right 4. So if you see 2 subtraction signs, it's like you've got the opposite of 7, which is negative 7, and the opposite of the opposite of, and then you've got the opposite of 4, which is negative 4, and the opposite of that is positive 4. I know that that's kind of confusing, so there's a few ways that you can look at it. One thing is if you see this and you have 2 negatives, some people just think if I just make that a plus, then it's negative 7 plus 4. So that's one way to look at it. What's really happening is that you really are saying I've got the opposite of 7, which is here, and I'm going to take the opposite of 4, which is negative 4, or I would be going that way, but I'm going to do the opposite of that, which is positive 4. So we're going to, subtracting a negative is the same as adding, so we're going to go 4 this way and he ends at -3. And so if we're looking at Tess then, so she is starting at -1 and is subtracting a -7. So she's starting at the opposite of 1, and then she's doing the opposite of 7, which is adding 7. So she starts here at 1, and then goes 1, 2, 3, 4, 5, 6, 7, and she ends at 6. So if we want to come down here, and let's move to 12 and write these as addition expressions. So here we had starting at -7 and adding 4. So we're going to write -7 plus 4. And here is -7 plus, or -1, sorry, -1 plus 7. And so then it asks us to simplify all of the expressions. So 2 plus -3, -1. We can check that up here on this expression right there. Yep. And -7 plus 4 is -3, and we can check that up here on our model. So starting at -7 and adding 4, we end up at -3. And then with -1 plus 7, we decided that it was 6 here. Okay, so let's go back and answer number 10. What is the same about all of the expressions on this page right here? What is the same? And what is the same is that they are all what operation? Right there, subtraction. And that's a subtraction problem, and that's a subtraction problem. But they all could be turned into addition problems. So they are subtraction problems that can be changed to addition problems. Okay, and what do you need to do to write a subtraction expression as an addition expression? And those should still be up at the front of the board, those steps. Step 1, the first number stays the same. Number 2 is change the sign or change the operation. And then 3, take the opposite of the second number. Okay, so the opposite of the second number. So then, if we look at that, here we said this was 2 minus 3. So at 2 minus 3, the first number stays the same. Let me get the mouse there. The first number stays the same. We change the sign from subtraction to addition, or change the operation, and we take the opposite of the number. So 2 minus 3 here, we take the opposite of +3, which is -3, and we get -1. -7 stays the same. We change the operation to addition, take the opposite of the -4, and that's +4. -1 stays the same, change the operation to addition, and take the opposite of -7, which is +7, and then we have that. So who has the slip of paper with the greatest value You guys can answer that question. And what is that value? And you guys can answer that question. All right, so compare the expressions on Mark's slip and Tessa's slip. When one negative number is subtracted from another negative number, when is the answer positive? When one negative number is subtracted from another negative number, when is the answer positive? So here we have one negative number subtracted from another negative number, but the answer is still negative. And here we have a negative number subtracted from another negative number, and the answer is positive. What's the difference? In this second expression, the second number is bigger than the first, and in this one, the second number is smaller than the first. So we can write that there. When one negative number is subtracted from another number, when is the answer positive? When the second number is bigger than the first number. And I should make a clarification. It's when the absolute value, that is not writing very well right now, is when the absolute value of that number, so that goes in there. So when the absolute value of the second number is bigger than the absolute value of the first number, the number is going to be positive. Okay, so now we're going to try it. You guys try these, spend a few minutes on these. So go ahead and pause the video for 4 or 5 minutes, and you guys can work on these, and then I'll solve them. Okay. 15, Jerry and Jane play a trivia game. Get the mouse there. Jerry and Jane play a trivia game. Jerry scores -17 and Jane's score is -24. What is the difference between Jerry's score and Jane's score? So the temptation here is just going to be to say, well, -17 plus -24 equals -41. That would be the temptation, is just to add those together, but that's not what this question is asking. This question is asking, what is the difference between Jerry and Jane's score? So what that means is we have a subtraction problem, because difference is subtraction. Okay, so let's set this up then as -17 minus -24. Okay. So if we follow the steps that we followed up here, when we're changing a subtraction expression to an addition expression, -17 stays the same. You change the operation, and then you change this to the opposite. So now we have -17 plus 24. And if we were to use a calculator there, or use a number line, -17 plus 24 would equal 7. So that's the difference. What that looks like on a number line, and why that makes sense, is if we have -24 here, and -17. So we would say to get there, we would go 1, 2, 3, 4, 5, 6, 7. So that's the difference between them. And it is a positive number. because the distance is always a positive number. So that's the answer to 15. Now, number 16, the table shows the highest and lowest elevations in Louisiana. New Orleans is -8, and Mount Driscoll is 535 feet. What is the difference between these elevations? So now we have a problem where we would say -8, because once again we're looking at the difference. So this is going to be a subtraction problem, and we could do this actually. We could say we could say 535. You might hear my cat meowing in the background, minus a -8. And what does that equal? Well, if we look at our rules again, this first number stays the same, so 535. We're going to change the operation from subtraction to addition, and we're going to add the opposite of -8, which is +8. So 535 plus 8 ends up being 543. So the key there is setting these up as subtraction problems. Here's what that looks like on a number line, and why this would make sense. So if here's 0, and here's -8, and all the way 0, -8, all the way over here is 535. Obviously this isn't to scale, but the distance between these two, you have to go +8 to get here, and plus 535 to get from here to here is +8, to get from here to here is 535, so the total is 543. All right, that is the lesson for today.